So we'll start the class with basics of networking. So before discussing CCNA, I'm giving basics of networking. Okay. So in basics of networking, we will discuss what is network, what is networking, how many types of networks are there, that we'll discuss here. So first, can anyone tell what is network? See, in these classes, we'll see how to configure the network, how to give communication, everything we'll discuss. But what is network? Network means physical connection or interconnection between two or more devices. So for example, now you have two pieces. If these two pieces wants to communicate with each other, one moment. Assume we have two computers. Okay. So now if these two pieces wants to communicate with each other, so first what we do, we give the physical connection. We'll give the physical connection between these two devices. This is called network. When devices are connected physically, so that we call as network. Physical connection or interconnection between two or more devices. Now, can they communicate with each other? These two devices are connected with each other. Can they communicate with each other? Can anyone tell?
Yes.
If two devices wants to communicate with each other, compulsory they require physical connection and logical connection. Here, physically they are connected with each other. You give cable connection from one device to another device. You give physical connection, and that we are calling network. But still they cannot communicate with each other, because if two devices wants to communicate with each other, any networking device, if two devices wants to communicate with each other, compulsory they require physical connection and logical connection. So there is a physical connection for these two devices, but still they cannot communicate with each other because there is no logical connection. Logical connection means IP address, Internet Protocol Address. IP address is a physical logical address of our system in a network. And IP is used to carry the data from one PC to another PC. See, physically we are human, but we have names to recognize, right? Same. If two devices wants to communicate with each other, compulsory they require physical connection and logical connection. Now, I'm giving the IP address to these two devices. IP address is assigned to these two devices. Now they can communicate with each other. Then we call it as networking. Remember, this point is important in networking, in any networking, whatever you're learning in networking course. Okay, this point is important. If two devices wants to communicate with each other, compulsory physical connection and logical connection is required. Physical connection means media. Logical connection means IP address. Okay, so network means interconnection or physical connection between two or more devices. Networking means communication between two or more devices. Is this point clear? These 2 points are clear? Network and networking.
Yes.
Yeah. And about physical connection means media and IP address. About IP address, it is very important and we have separate class also. About physical connection means about media also I'll explain. Okay. As of now, I just explained what is network and what is networking. Network means physical or physical or interconnection between two or more devices. Devices means networking device. It can be PC, switch, router, hub, whatever it is. Okay. Networking means logical connection between two or more devices. So can you tell me what is the advantage of connecting multiple devices together? What is the advantage of network in our organizations? Why they are connecting all the devices in a network? What is the advantage of that?
Communication purpose.
Individually also we can communicate. Why network?
Resource sharing.
Exactly. Sharing resources. Advantage of network is sharing resources. Resources means hardware and software. If the devices are connected together, we can share the resources. Resources means hardware and software we can share from one device to another device. So assume, I'll just give one example. Assume you have an organization, small startup company is there. Okay, there are 100 computers, new computers you purchase, there are 100 computers. From every computer, you want to take printouts. And further, you want to take printouts from every piece, every computer. Okay, so one computer is not connected to another computer. 100 individual computers are there. They are not connected into a network. Right. So how many printers are required now?
100.
I'm repeating question. I have 100 individual computers. It means one computer is not connected to another computer. Fine. Now I want to take printouts from these 100 computers. How many printers are required? Exactly. Now 100 printers are required. If you want to take printouts, means from these 100 machines you want to take printout, you need 100 computers because one is not connected to another one. So 100 printers are required, but purchasing 100 printers means it is expensive. Still, you're not bothering about expensive also. It occupies more space. That is matter. It occupies more space in our organization. 100 printers means it occupies space. Administrators work is more, they'll get confused and expensive also. It is very expensive also. And if you want backup printers means again we'll purchase some extra printers also for backup purpose. So that is very expensive. And what is method in a organization? Okay, so instead of this, what you did is as an administrator, you established one network by using centralized controller like switch. Not what you will do is you'll take a switch, you'll connect all these PCs to that switch. Okay, so now all 100 PCs are in a network. How many printers are required to take printouts? How many printers are required this time? Yes. Now 100 PCs are connected into a network.
Only
Okay.
one. Only one printer.
Yeah, only one printer is enough this time. Now what you will do? This 100 printers you will connect to one switch. Even printer also you will connect to that switch. So now all are interconnected with each other. So now what you will do? We'll take all the pieces. So are connected and printer also available. One printer is there. You'll take printouts from that printer itself. Only one printer is enough. No, your workload is more. All 100 pieces are working. So in that scenario, you can go with another printer or you can purchase 10 printers also, no issues, instead of purchasing 100 printers. If you're purchasing 10 printers also not a problem, right? But one printer is enough. If all the pieces are connected with each other, only one printer is enough to take printouts from the 100 pieces. That is sharing hardware resources, printers, scanners, hard disk, everything we can share. Okay, now coming to software. Now, same scenario, there are 100 PCs, individual computers. One computer is not connected to another computer. In your first computer, there is an important data. The same data you want to share with remaining 99 PCs also. So how we share the data to remaining 99 PCs? There is an important data. Okay, in your first computer. You want to share the data to your 99 computers, remaining 99 computers. How we share the data? That is the question. Yes, Sam, I will discuss IP version 6 also, but not now. After some more sessions. And CCNA, middle, I'll explain about that.
Then you have to establish networking to all 100
Sorry?
computers.
All the 100 computers are not connected into network. Individual 100 computers are there. There is no network connectivity. Then what to do? Simple. Take one external device like pen drives, external hard disk, copy the data into that external device, then connect into your second PC, connect it into your second PC, paste the data, and go remove the pen drive, connect into third PC, copy the data, and again remove from third PC, connect it into fourth PC, and paste the data like that. But this process takes time. It takes long time to transfer the data to all remaining 99 pieces, right? Connecting the device, pasting the data, removing it, connecting into another device, pasting it, it takes time. Instead of that, if you connected this 100 pieces into a network, we can create a folder, we can add the data into that folder, and we can give share permissions to that folder so that everyone can access the data. From the first PC, everyone directly can access the data if the devices are connected into a network. Okay, so We can share software resources also if the devices are connected. So advantage of network is sharing resources, hardware resources and software resources we can share from one device to another device. Is this point is clear?
Yes, ma'am.
How to give the connectivities that I will show here. In further classes, practically I will show how to share, give the connectivities from one device to another device. Okay. And Sam, I already mentioned the syllabus in the last session. Maybe you are not there in the last session. If you check the last class video recording, you will get that notes. Syllabus details. Clear, Sam? Done.
Ma'am, I think you are on mute, ma'am.
Audible?
Yes, ma'am. Now, okay.
Okay, okay. Types of network. Any idea? Types of network? LAN, MAN, WAN. Local area network, metropolitan area network, and wide area network. There are three types of network. Even we have campus area network, home area network, which comes under LAN only. Okay. So there are three types of networks: local area network, metropolitan area network, and wide area network. Okay, which type of connectivity we call as LAN means when the devices are connected within a building, within a campus or building. Devices are connected with each other and sharing the data. Then we call it as local area network. I'm repeating again. When the devices are connected within a campus or building and they are communicating with each other, that type of connectivity we call as LAN. Now you are working in one organization. In your company, all the PCs are communicating with each other. That type of connectivity is called as LAN. Next is MAN. Within a city, if you have multiple branches, within a city, you have multiple branches. And one branch able to communicate with another branch. One branch is communicating with another branch. That type of connectivity we call as MAN. And WAN, wide area network. Now you have one branch in Delhi, one branch in Hyderabad, one branch in Mumbai, one branch in Bangalore, Kerala, like that, different cities or in different geographical areas. If the branches are there and they are communicating with each other, that type of connectivity we call as WAN. Example for WAN is www, World Wide Web. It is nothing but internet. When the devices are communicating with each other between different geographical areas. So that type of connectivity we call as WAN. So LAN means you have a building, the PCs are communicating with each other. So that we call as LAN. Now you have within the city, you have branches. One branch is in one location, one branch is in another location. Okay, so here you are using one LAN connectivity and here you are using one LAN connectivity for communication purpose. And when these two LANs are communicating with each other, group of LANs are communicating with each other, that we call as MAN, Metropolitan Area Network. Now, you have branches in different geographical areas and they are communicating with each other. That type of connectivity we call as WAN. The type of connectivity we call as WAN.
One small doubt, Madhuri.
Yes.
Yeah, in LAN and MAN, do we have the concept of internet?
Internet is our wish. See, without internet also, within the LAN, PCs can communicate with each other. If you want to access internet, then we'll take the connectivity.
Okay, so in LAN and MAN, without internet also, there can be connectivity. That's what you're telling.
Exactly.
But in WAN, there must be internet.
We completed Linux, no? Previously, in previous Linux, I showed you how to share the data using NFS and Samba. Did you remember?
No, I have not gone. I'm halfway through. I'm not completed that yet, actually. Yeah.
Okay.
So
Actually, without internet connection also, if you have LAN connection, we can communicate with each other. Example, you have two laptops with you. If you have cross cable and one PC is these two PCs are connected using the cross cable means you can share the data from one PC to another PC without internet connection.
Okay. But in WAN, there have to be internet. There must be internet. Right?
Yes. Compulsory. And next is internetwork. This is not internet. This is internetwork. Internetwork. Interconnection or physical connection between two or more different networks. When two or more different networks are connected with each other, we call it as internetwork. Internetwork. Logical connection. Logical connection between two or more different networks. Logical connection between two or more different networks is called internetworking. I'm not talking internet, I'm talking about internetworking. I'll give you one example for this.
This can be LAN connection with WAN. Any combination can be there, right?
Yes, I'll show it. Now, I have pieces. Assume we have a department, we have a CCNA department. In our department, we have these pieces. Can they communicate with each other? Now I have multiple pieces. Can they communicate with each other now?
No.
Yes or no?
No.
No. Simple. If two devices wants to communicate with each other, compulsory they required physical connection and logical connection, as we discussed. Remember that point. If two devices wants to communicate with each other, compulsory they required physical connection and logical connection. We have devices. There is no connectivity. Right. Now, I'll take one centralized controller. All these connections, everything in further classes, I will show you. Okay. Don't concentrate on this connectivities, everything. Just and concentrate on the theory what I'm explaining. Everything practically I will show in further classes. Now, I'm giving the physical connection from PC to this switch. I'm using one switch as a centralized controller so that all the devices I can connect. Now, physically, these devices are connected with each other. Can they communicate with each other?
No.
Still no, because there is no logical connection. IP address is not there. Only physically they are connected. Now, I'm assigning IP addresses to these pieces. When we give physical connection, that is called network. Now, I'm giving the IP addresses to these pieces. Now, this is called networking. All these devices can communicate with each other. This is called networking. Okay, so now this is my CCNA department. Now, I'm establishing another department. This is my CCNA department with 192.168.1.0 network. Now I'm taking another network. Now I have another department. Assume this is my Linux department. Here also I have multiple pieces. In this department also, I have multiple pieces. I want to give communication between these pieces so that I can share the resources. So for that, what I'm doing is I'm giving the connection. I'm taking one switch. And I'm giving physical connection between these devices. One and two PC, other and two switch. Similarly, see this we have practical also in our further classes. I will show at the time. I'll explain and I will show every point. You will do in further classes these connections. Now physically they are connected with each other. This is called network, physical connection. Okay, so an interconnection between two or more devices is called network. Can they communicate with each other? No, they cannot communicate with each other because they required IP address. Now assume we assigned IP addresses to these pieces 192.168.1, 2.1, 2.2, 2.3 like that by using one network 192.168.2.0 network. I assigned IP addresses to these pieces like 192.168.2.1. One 192.168.2.2 and 2.3. I assigned IP addresses to these spaces. So now here also one network is there. This is one network and this is the network. They can, here all the devices are communicating with each other. Here all the devices are communicating with each other because they are connected physically and logically. Assume. Now, these two departments wants to communicate with each other. These two departments wants to communicate with each other. Is it possible now? In this scenario, is it possible?
No,
No. Why no?
there is no physical and logical connection between these two.
Exactly. There is no physical and logical connection between these two devices. So for physical connection between these devices, okay, if I'm taking a cable, assume cross cable. What is the cable also we'll see next. If I'm taking a cable and if I'm giving the connection from here to here also, that is not possible because physically they are connected. Using the cable, I give the physical connection from first switch to second switch. I give the connection. But the problem is, in my CCNA department, I'm using 192.168.1.0 network, whereas in Linux, I'm using 192.168.2.0 network. Networks are different, right? So what IP address we assign to our switches? If two devices wants to communicate with each other, compulsory they require physical and logical connection. Physically they are connected, but logically we cannot give IP address because they are using different networks. Two different networks cannot communicate with each other directly. Remember, two different networks cannot communicate with each other directly. So now if I give the physical connection also, no use of that because they are in different networks. So in this scenario, what we do means, we'll take a router. Router is a networking device which gives communication between two or more different networks. So now what I will do is, I'll take a router here, and here also I'll purchase one router. Okay, and then I'll give the physical connection. From router to switch, I'll give the physical connection here. And other end also, from router to switch, I'll give the, one second. From router to switch, I'll give the physical connection in other end also. Okay, now my router can communicate with, see, this router is connected to this network, this router is connected to this network. Again, we also require the connectivity between these two routers. Then what I will do is, I'll give the connection from first router to second router. I'll give the physical connection. The zigzag line indicates WAN connectivity. The zigzag line indicates WAN connectivity. So now I'll give the physical connection from first router to second router. All the devices are connected with each other physically. Then it is called internetwork. Internetwork means interconnection or physical connection between two or more devices. Now router to switch, switch to PCs are connected, and from source side to destination side, router to router is connected. In destination side also, means in my second router also, router is connected to switch, switch is connected to PCs. So all are connected with each other. Then it is called internetwork, interconnection between two or more different networks. CCNA department is one network and Linux department is another network. Okay, now we give the physical connection between these networks. Then it is called internetworking, internetwork. Can they communicate with each other? Can they communicate with each other now?
Yeah. I think so, ma'am. I
Till
could be wrong.
they cannot communicate with each other. Why? Can anyone tell? Still these devices cannot communicate with each other. Can anyone guess? Wrong also, no problem. Just an answer.
No idea, ma'am.
Still they cannot communicate with each other because they're required. Someone said something. Let me check. Exactly, Shivraj. Still they cannot communicate with each other because they require logical connectivity. Physically they are connected, but logically they are not yet connected. Now what we'll do is, we'll assign logical connection also. Example 192.168.1.4 connection, which is there for router to switch. For that connection, I'll give IP address, this one. And now router to router connectivity is there, no? For that, I'm giving another IP address, 10.0.0.1 example. This end, 10.0.0.2. This end I give the connection. And the connectivity for router to switch, also I'm assigning one IP address, 192.168.2.4, which from your local network. For router to router, we'll assign IP address from the same network. And from router to switch, from this network, I assigned one IP address here. Other end also, from this network, I assigned one IP address. Okay, so now you will get confusion by this. When I show you practically in further classes, you will understand everything clearly. So now all the devices are connected physically and logically. Now this is called internetworking. Internetworking means giving communication between two or more different networks. giving communication between two or more different networks is called internetworking. Internetwork, interconnection between two or more different networks. Internetworking, communication or logical connection between two or more different networks. How two or more different networks can communicate with each other? By using router.
Madhuri, can't we assign IP address here for a switch?
We can assign IP address.
For a switch also.
Yeah, for switch also we can assign IP address. I will show that also in
Okay,
coming
so
classes.
what is the basic difference between a switch and a router? In terms of
Switch.
its functionality?
Switch is centralized controller. Switch is used to connect multiple pieces together. That's it. Within a LAN. You have multiple pieces. You want to combine all the pieces together. For sharing, we use a centralized controller. It may be hub, it may be switch.
Okay.
But router is a networking device which gives communication between two or more different networks. In this scenario, if you observe, this logical connection is 192.168.1.0. This is 1.0 network and this is 2.0 network. Two different networks we have. When you want to give communication between two or more different networks, there we use router. Within a network, you want to share, the pieces will go with switch.
Thank you.
Is that clear?
Yes, Madhuri, thank you.
Yes. All these points we'll see practically also. And you may don't understand this. What is this 192.168.1.0? What is this 192.168.2.0? You may get confusion now. But we have a class IP address. At that time, you'll understand what is this network, why I'm using the word different networks, that word. The terminology you'll understand at that time. Okay, so router is a networking device which gives communication between two or more different networks. When you want to give communication between two or more different networks, we go with router. Okay, so we have types of routers. We have two types. Software router and hardware router. Software router is nothing but it is a PC. It is a PC. Software router means we'll take a PC, we'll take a server here. So in this server, we'll insert two LAN cards. In this server, we'll insert two LAN cards. From one LAN card to switch will give the connection. From one LAN card to switch will give the connection. Other end also, from other LAN card to switch, other switch will give the connection. Software router means. Okay, so now what we do is, for this LAN, we'll assign one IP address from this network. Example for this LAN, 192.168.1.5, something IP address I'll give. For this LAN, I'll assign one IP address from this network, 192.168.2.5, like this. This is not router. It acts like a router. This server, here we can install Windows Server or Linux operating system. There is an option to enable router. Router option will be there, will enable in this machine, server machine. Okay, it acts like a router. This is not router, it acts like a router. So where we use this software router means when we have less number of networks. Okay, so there we go with software router. That is one point. Why less number of network? Because now I have two different networks. So I inserted two LAN cards in this server. If I have 10 different networks, I cannot insert 10 LAN cards, right? Our systems will not support. If you have 20 different networks, we cannot insert 20 LAN cards in this server, right? It will not support. So in that scenario, we don't use software router. That is one point. And second point, below 100 meters only, we can use software routers. Software routers can be used below 100 meters. This is important. Software routers we can use only in below 100 meters. Because we cannot extend the cable more than 100 meters. Directly, we cannot extend more than 100 meters. Now, assume this network is in Hyderabad. This is there in Delhi. These two are in different geographical areas, right? In that scenario, you cannot go with software router because software router can be used in below 100 meters only. If the networks are in different geographical areas, we go with hardware router. Okay, so there are two types of routers. First point, router. What is router? It is a networking device which gives communication between two or more different networks. And in router, we have two types, software router and hardware router. Software router means it is a machine. There we install server operating system. It acts like a router. Where we use software router? Where we have less number of networks. In below 100 meters, we go with software router. When we have networks in different geographical areas, we go with hardware router. Point clear?
Yes, Madhuri.
Then everything I will share the notes also. Once you register, you'll get the Telegram link. I'll share the notes. Here, what we are discussing, this router is different. And in our home or in our colleges, we use routers, right? That is different. I'm not talking about that. Actually, that is access point. It is used to access internet. In our home, we use routers, right? That is access point. It is used to access internet connection. We just access internet connection. Nothing we do using that. We access internet.
Okay.
Now, what we are discussing router is different. Here we can do different configurations, different security connectivities we can do. Okay. So in real time, worldwide, for communication purpose, we are using the routers. This routers only. This we are using. Okay. What we have in our home, that is access points. I am calling like router, but actual name is router. We call it as, we pronounce it as router, but actual name is router. Route means path. It gives path between two or more different networks. So this is router purpose. Is this clear, everyone?
Yes, Madhuri.
Yes, ma'am. Yeah. Hello. Yeah,
Yes,
good evening,
ma'am.
come in. Okay, I'll close. Wait. Done. So in this session, we discussed about network, networking, advantage of network, types of networks, and what is internetwork, internetworking, and what is router. That is what we discussed in today's session. Okay, and next is basic requirements. If you want to connect our system in a network, what we require, basic requirements are what? If you have 2-3 PCs, You want to connect them into a network and you want to share the data from one PC to another PC. What are the basic requirements? Okay, so that we'll see in our tomorrow's session. So this is for today's session. Thank you so much for the session. Okay, so we'll meet tomorrow at 7 p.m. I'll try to end the class before 5 minutes so that you can ask questions also if you have any doubts. I don't
Thank
check
you.
the time today. Yeah. Thank you so much.
Thank you, ma'am.
Yeah.